All right, so welcome in. Here's an example, and we're going to be applying Poiseuille's law in order to solve this. The reason why I bring this up is just to show students that utilizing the formula itself when things are given to you is not that difficult, and also sometimes seeing a numerical example makes things a lot easier to think about on how to apply such equations or formulas. So here it is. So we have a water pipe. Okay, the coefficient of viscosity of the water flowing in this pipe is 1.05 millipascal seconds. Okay, so that's what's given. This particular water pipe is 25 meters in length and 1 inch in diameter. Okay, it is being tested for its flow rate due to abnormalities of the flow along the pipe due to some partial blockage, okay, at the 11 meters, okay, kind of line along the pipe. So before I jump into the rest, let's try to draw this out so that we can visually see what is happening. Okay, so let's imagine we have this pipe in here. So let me try, okay, as best as I can here to draw this out. So I'm gonna kind of take this pipe and let's assume now it's going to be only 1 meter in diameter. So I'm not going to make it too tiny, but you can imagine that this whole entire pipe, it tells us is 25 meters. And ideally, we would want the flow, okay, on the inlet coming in, and then the flow on the outlet coming out, and nothing really major, okay, in terms of changes. We would not want to be happening in terms of the flow. But for some reason, okay, they tell us that there is some kind of a partial blockage. Okay, and this partial blockage is happening at 11 meters. All right, so let's imagine, the 11 meters is somewhere along there, and we want to be able to find, okay, what that is. So let's say from here, all the way up to here. So that would have been, 11 meters. Now, the rest of the information that's provided, okay, so I'm going to just write it out in here for us. So the given pieces of information that we have. So we have the coefficient of viscosity. Okay, so notice this is 1.05 millipascal, okay, seconds. I'm going to change this back to metric standard units, and that is something which is worthwhile for you to do. If you're going to take a look at any formula, the safest thing to do is typically put the actual units back to standard units, and then you can do your calculations and then come back and then change if you have to change to something different. Although I can see here that in the question, they do want things to be kept in SI units. So I'll start right away to do that. So millipascals, so that means this is going to be rather small, but that's fine. So we have this, and that is our coefficient of viscosity. So because of the milli, okay, we're just going to move the decimal over 3 decimal places. All right, so that's one of the things. We have our diameter, so that means our radius, okay, is going to be half our diameter. Now notice it says it's 1 inch, which is 2.54 centimeters. So I'm going to just write this out, 2.54 centimeters, but this is of course divided by 2 because it would be the radius. So again, in metric standard units, 0.0254, because from the centi into kind of meters, so this is what it's going to be, and we can certainly find out what that will be. So let me just plug it into the calculator, just so that I don't have to carry that 2, at least for the moment. You can if you want. Okay, so this one nicely works out. So we have 0.0127 meters for our radius. Okay, so that's so far those 2 pieces of given information. And now our length, okay, so this will be from the starting point, so right here, to the actual blockage. Okay, so we have this, which is 11 meters. Okay, so that's what we are going to try to work out at. Okay, so this would have been our length that we have, and it is 11 meters. So we are going to need, because of the change in pressure, so we're going to have kind of the pressure, okay, which is coming in, okay, and this is the pressure at the blockage. Okay, so this is the changes in pressures that we want to be able to see. All right, so let's keep reading. If you know that at the inlet of the pipe, the pressure is 85 psi. Okay, so we have 85 psi in here, and they do give us the actual conversion. So I'm going to kind of just put in here. So pressure at the in is equal to 85 psi. And then hopefully I have the pressure, the blockage. Okay, so if you know that at the inlet of the pipe, the pressure is 85, and at the blockage, the pressure has dropped to 55. Okay, so there is, a drop in here, and this drop, okay, is 55 psi. So that's happening, okay, at the blockage there. So P, I'm gonna just put blockage, is 55. All right. So we have that. Now you can certainly change this to SI units. So you can put this into SI units. You can put this one in SI units. But notice that in the actual formula, we have the change in pressure, right? So this is from the high to the low always, okay? So Poiseuille's law, that's the pressure difference that we have. So if I write this out as a pressure difference, so the change in pressure, which is going to be 85 minus 55, really, so this is 30 psi. And this is really all I need. So I'm going to just change this to SI units. So multiplied by, so 1 psi, and this is going to be 6895 pascals. 6895 pascals right there, okay, equals. So the psi's will change, okay, and remove themselves out of the equation in there. So we have 30 multiplied by, so 6895 equals. So this is quite a bit, okay, of a change in pressure that we would have in terms of pascals. Notice that this is, almost twice as big. Yeah, it is actually more than twice as big as the atmospheric pressure changes. Okay, so now I have all of that, and we want to be able to find out what the flow, okay, is present at the blockage. All right, so if I take this formula, I'm going to have to try to substitute everything into here. So here's my change in pressure, here's my radius, here's my viscosity that I have, and then here over here is the actual length. Now this particular length is from the changes from one pressure to another. If you had this for the entire pipe, and then maybe the pressure has changed from the beginning to the end, you can certainly try to find out what that is. So here is we have some partial blockage and we know what the pressure drop is. So we'll do that calculation. All right, so now let me maybe change the color in here. So the volume flow rate, sometimes this is designated as Q. Okay, so it depends. I like to just write volume flow rate as it is. It doesn't really matter, okay, what you call it. But here we have the change in pressure. So that's going to be 206,850. So that's my change in pressure multiplied by, so this is going to be by pi, multiplied by, this is going to be, so multiplied by the radius. So notice the radius is 0.0127. This is going to be to the 4. And then this whole thing is going to be divided by, so based on the equation right there, it's 8 times the viscosity. So viscosity right there is 0.00105. And that is all in metric standard units. And then finally the length, which is at 11 meters. All right, so that's what we would have over here. And now I can substitute this into my calculator and then get what my answer is. Okay, so let me do that and then I'll be right back. All right, so there you have it. Okay, so it's about 0.18295. They do tell us to round to the 10th, so we can certainly round this off. It's going to be 0.2 meters cubed per second. All right, so it's quite a bit, okay, of flow that you would have actually in here. And that is it, okay? So once you can substitute this back in here, it's just a matter, to be honest with you, just keep things in standard units and it makes life a lot easier for yourself. And I hope that this example just kind of illustrates to you, how this formula is actually applied. Because when you're just taking this in on the introductory side in terms of fluid dynamics, you sometimes get thrown off. It's actually not that hard. Of course, the hard component is, how Poiseuille actually came up with this formula. But that's beyond this particular video. Okay, so here we just want to be able to take the formula, apply it, substitute all of the different givens, and understand what those givens are, be able to change them to SI units as needed, okay, and then do the calculation. All right, so thanks for watching. Okay, hopefully we'll see you in future videos. Bye, everybody.